in this section, we're going to be talking about dividing monomials. So like we've already talked about before, if exponents are treated like naughty little kids and they're always a step behind, my kids do what they're told. They divide those coefficients. But since my exponents are naughty and they're always a step behind, they're going to subtract. Okay? So that's my rule. So if I'm dividing, I subtract and I get A minus B. So just like over here, x to the fifth over x to the third is going to be x squared. Because what this really means, and let me talk about the meaning, is that if you had this written as x times x times x times x times x, all over x times x times x, anything divided by itself cancels out. So these guys cancel out, these guys cancel out, and these guys cancel out, and you're left with x squared, and it's positive, so you have more on top. So that's how we're getting x squared, so we subtract our exponents. That's the shortcut we use, that's the rule, because you sure don't want to expand that out if it's x to the 503rd power over x to the 205th. You couldn't write x that many times. You could, it would just take long. So over here on number 2, I get k's are the same, so I get k to the 10th. Now, on this one, I want you to put a star by this, because this is a big rule. If I expanded this, I would get m times m times m over m times m times m. My m's cancel out, my m's cancel out, my m's cancel out, and anything divided by itself is 1, so here I just have left as 1. So the big takeaway here is that if I subtracted, I would get m to the 0 power. So what you have to remember is anything to the 0 power is always going to be 1, because everything cancels out and it leaves you with 1. Okay, so on a quiz, if I gave you something crazy like 2x to the 5th over y to the negative 6 over 15x to the 4th, y to the 24th, all raised to the 0 power, your answer here is going to be 1, because anything to the 0 power is always 1. Okay, let's go through number 4. If I look at number 4, so if I subtract my a's, I get 6 minus 2 is a to the 4th, and I get b to the 1st, 4 minus 3 is b to the 3rd, which is just 1, so I'm going to keep it like that. Here I would have p to the 3rd, 7 minus 4 is 3, and 16 minus 12 is q to the 4th. Over here, I have 20 minus 5, and I get x to the 15th. Here, I have 9 minus 9 is 0, which just means they cancel out. Anything divided by itself cancels out, becomes 1. And then here, I have z to the 2 minus 1 is 2 to the 1st, but I just keep it as z. Okay, so when we go down here we just treat them. We treat our kids like they just do what they're told. 6 divided by 2 is 3. Subtract my exponents, and I get x to the 1st. Here, 14 over 7 is 2, and then I subtract my r's. 2 minus 1 is just r to the 1st, and then I have s. 2 minus 1 is just s. So that's my final answer. Over here, negative 36 divided by 4 is negative 9. My c's cancel out because that's to the 0 power, which is 1, and then I get d squared. Over here on number 10, I have a negative 15 divided by negative 3, which is positive 5. I subtract 6 minus 5 is x to the 1st. I subtract y, 5 minus 3 is y squared, and then you've got that z that doesn't subtract with anybody, but you still got to account for him. Look at number 11. This is reducing, so I can reduce to 1/2, and then I get 5 minus 1 is n to the 4th. So my variables are still going to land up top. Okay, over here I'm going to reduce. I know 9 goes into 36 4 times, and 9 goes into 54 6 times, and then I can reduce again to get 2/3. So 2/3 is going to be my fraction, and then I subtract. 9 minus 3 is to the 6th, and 5 minus 2 is to the 3rd. So 2/3 n to the 6th, n to the 3rd. All right, as you look down, here we have some mixed practice going on. So you're going to do the numerator first, or the denominator. So if I do that, remember this is an exponent rule. So my Kid does what he's told. 3 squared is 9. And then my exponents are a step behind, so they're going to multiply. 5 times 2 is x to the 10th, divided by 27x to the 3rd. And now I can reduce again. 9 over 27 reduces to 1 over 3. And then my exponents I subtract. 10 minus 3 is x to the 7th. Okay? Over here, this is an exponent rule. So 2 to the 3rd does what he's told. 2 times 2 times 2, which is 8. My exponents multiply, so I get a to the 6th, b to the 12th, all over 4a to the 3rd, b to the 7th. And now 8 over 4 reduces to 2. And then I subtract. 6 minus 3 is a to the 3rd. And 12 minus 7 is b to the 5th. So this would be my final answer. Okay, let's do number 16. So again, I'm doing 2 to the 4th, which is 2 times 2 times 2 times 2. So 4 times 4 is 16. My exponents multiply, so remember that's c to the 1st. So 1 times 4 is c to the 4th, and d to the 16th because they multiply. All over 2 squared is 2 times 2, which is 4. These guys multiply, so I get c to the 4th, d to the 6th. And then, of course, I can keep going. 16 divided by 4 is 4. My exponents subtract. 4 minus 4 is 0, which is 1, which means they cancel out. Anything divided by itself cancels out. And here I have d to the 16 over d to the 6, so I subtract 16 minus 6, and I get d to the 10th. So that's what that guy looks like. All right, let's take a look at some more. And we're going to do let's do these last 4. So all you have to really do here is just take it step by step. Remember your rules. Don't make up rules. And if you remember them, then it's going to come out okay in the end. So here I'm going to multiply. These guys do what they're told. 8 times negative 3 is negative 24. Now, I would write over here, please excuse my dear Aunt Sally, so I can look to see what is my exponent rule. Well, if these guys multiply, my exponents are a step behind, so they add. So I get c to the 5th, d to the 3rd. So I've multiplied all that. All over 6c squared to the d. So I'm going to negative 24 over 6 is negative 4. I subtract my exponents. 5 minus 2 is c to the 3rd. Subtract 3 minus 1. There's an understood 1 there. And I get d squared. Don't forget about this guy. Negative 9c cubed d squared. Before you do that, you have to ask yourself, are you allowed to do that? When you add and subtract, remember, they have to be exactly the same. C cubed d squared, c cubed d squared. You are allowed to do it. So now my coefficients do what they're told, negative 13. And what do my exponents do? Nothing. There's nothing there. You can't change them. So it's c to the 3rd d squared. So that's my final answer. Okay, let's take a look at number 26. Same thing. I'm going to multiply up here. So it's a multiplication rule. So these guys do what they're told. 8 times 3 is 24. And I add my exponents because my exponents are a step behind. So I get r to the 8, s to the 6th, all over 12r s to the 4th. Now, 24 divided by 12 is 2. I subtract my exponents. 8 minus 1 is r to the 7th. 6 minus 3 is s squared. And then you bring down this guy. And before you do it, you have to ask yourself, are you allowed to combine these terms? Well, yes. R to the 7th, s squared is exactly the same. So my coefficients add, and my exponents do nothing. You cannot change them when you're adding and subtracting. Okay, let's look at number 27. All right. So we got a couple things going on here. Let's do this first. This is an exponent rule. So over here, I'm going to put my rules. This is an exponent rule. So my kid does what he's told. 2 to the 3rd power, 2 times 2 times 2 is 8. And my exponents are a step behind, so they multiply. So 2 times 3 is n to the 6th. And then you're still multiplying it by this guy. So 3 to the 3rd power, that's an exponent rule. 3 times 3 times 3 is 27. And then I multiply. 4 times 3 is n to the 12th. Okay, so now couple things you can do. You can do 27 times 8, and I get 216, and then I add my exponents, but I can't add m and n, so I'm going to keep m to the 6th, n to the 12th, all over this denominator, 9m to the 4th, n to the 7th. Okay, so now I divide. 216 divided by 9, 9 goes into 21, 2 whole times with 3 left over, 9 goes into 36 4 times, so 24. And then here I subtract my exponents, so I get m 6 minus 4 squared. 12 minus 7 is n to the 5th. So we did all this, but don't forget to bring down this guy. Negative 18 m squared n to the 5th. And before you do it, you have to ask yourself, are you allowed to do it? Yes, you are, because m squared n to the 5th is exactly the same. So now I get 6, and my exponents do nothing. You cannot change your exponents because you were just combining like terms. So that's what that guy looks like. All right, let's take a look at number 28. So I have negative 6 squared. Negative 6 squared is a negative 6 times a negative 6, which is 36. And that's an exponent rule. So my exponents that are a step behind are going to multiply, and I get x to the 8th, y to the 12th, all over negative 3 squared, which is negative 3 times negative 3, which is positive 9. And then I multiply 3 times 2 is x to the 6th, 5 times 2 is y to the 10th. So now I can simplify this. 36 divided by 9 is 4. I subtract my exponents. 8 minus 6 is x squared. 12 minus 10 is y to the 10th. Don't forget to bring down this guy. Oh, excuse me, 12 y to the 2nd. 12 minus 10 is 2. Don't forget to bring down this guy. And before you can combine them, you have to ask yourself, are you allowed to combine them? Yes, x squared, y squared is exactly the same. So now I combine them, and my exponents do nothing. They don't do anything. There's nothing to do if they're a step behind. Okay, so this is just bringing them all together. So if you have questions, come see me sooner rather than later.